When you're translating hyperbolas, you can follow all of the same rules as the other translations that we've made. So having a look at the basic hyperbola here, this is a basic hyperbola, y equals something over x. Now remember, this something can be any constant, and what that will do as this number changes in size, it makes the waist of this fatter or skinnier. But they all have this basic same shape with two arms. We need to label a point on each arm by just letting x equal something and seeing what y will be, so that we have at least a point on each one labelled for scale. And then you need to draw in your asymptotes, those points that x and y can never be. And we have asymptotes on the x and y axis with this graph because you can't divide 2 by 0, it doesn't compute. And if you have 2 divided by anything, you can't get 0 either. So that creates these asymptotes, which you need to draw in. Now, if we want to shift the graph to left or right, we need to make changes to x and let it be x plus something or x minus something. X minus something will move to the right, and x plus something will move to the left. So again, we have, well, let's just do one. All right, the plus 1 is tied in closely with what the x is doing. What is the x doing? It's being on the bottom of a fraction. Okay, it's not a plus 1 tacked onto the end out here. So this tells us that we've got to move the graph left or right, and the plus tells us that we're moving to the left 1 unit. So the first thing to do is just think about what's happened to your asymptotes. If you've moved this graph 1 step to the left, then this asymptote will now be sitting here at -1. The other one we haven't changed because we haven't moved up and down, is still in the same place. And then we can draw in our two hyperbolic arms like this. And all we need to do now is label any intercepts that we have and make sure we've got at least 1 point labelled on each arm. Now, the most sensible thing to find would be this intercept, because it can double as labelling an intercept and a point on the arm. So to find that, let x equal 0 and y will equal, we'll just sub the 0 in here, 2 over 1, which is 2. So we've got that point done. Now we just need to label a point somewhere over here. So it needs to be somewhere where x is less than -1. Let's say let x equal -2, a nice round number. Y will equal, well, we'll have 2 over -2 plus 1, which is -1. So y will equal -2. So we have this point here, -2, -2, which we can label like that. And our graph is pretty much done, and we have the working here to show how we figured out our points of interest. If we want to shift one of these graphs up and down, then instead of putting the translation closely in with what the x is doing, remember we need to substitute y plus or minus something for the y. Now if I do y, let's say -1 equals this same graph that we have over here, remember the net effect of doing this is that I could add 1 to each side, which would pretty much give me a y on its own here and a +1 over here. And we sort of prefer looking at them in this form because we've got the y equals something. It's more of a generic sort of form. So we're getting to know that this +1 that's tacked onto the end moves our graph up or down, and the +1 means that it's gone up 1 unit. So to draw this in, we think about what's happened to our asymptotes first. They've moved up 1. So we have this asymptote sitting here at 1, and the other one is still where it would have been. And we draw in our arms. This one will have no intercepts at all, and this one will have an intercept right here. So we'll need a point on this arm, and we'll need to figure out what this point is here. So let's figure out this one first. For this one, we need to say, well, it's an x-intercept, so we need to let y equal 0 and see what x comes out as. 0 equals 2 over x plus 1. Taking 1 off each side, -1 equals 2 over x. And then solving this, x will equal 2 over -1, which is just -2. So I can label this point -2 here, and here's the working I used to figure it out. Up here we just need any old point, so I'm going to say let x equal 1 and find out what y is. 2 over 1 is 2, plus 1 is 3. So that one was nice and easy. I'm going to label this point 1, 3. And we're done. Now, if you want to move a graph left and right, you'll have a plus or minus something here, and up or down at the same time you'll have something tacked in here, and you can easily label and graph those. It's just a matter of always thinking about what your base graph would be and then shifting it up, down, left and right. Probably another good skill to practice is actually looking at a graph and figuring out what its equation is, so sort of working backwards. So let's give ourselves a little bit of space here. If I have a graph like, let's just say we draw in an asymptote here at 3 and another one here at -2, and then we give it that nice hyperbola shape. I've got an intercept here at 5. Well, that's not very well drawn then, is it? Let's draw it a little bit better. Well, still not very good. Let's make it a lot skinnier. And we can make this 5. And this one can be -3 1/3. And my question would be, what is the equation of this function? Now, to figure it out, we know its basic form is y equals a over x. But that x has been moved around a little bit. We've obviously shifted this thing across 3 units to the right. And that tells me we need an x -3 here. We're not sure what the a is, so for the moment just put a. We don't know how fat or skinny this graph is. We've also shifted the graph down 2, which means I need a -2 at the end here. Now, how can I figure out what this a is? All I really need is 1 point on the graph, and I've been given 2. I'll use this one because 5, 0 looks like a nice simple point, and I can substitute x equals 5, y equals 0 into here so that I can find a. All right, when y equals 0, x equals 5. 5 -3 is 2, -2. Add 2 to both sides, 2 equals a over 2. So a must equal 4. So I can now rewrite my equation. Y equals 4 over x -3 -2. And I'm done.